test tube, Tina's Weird Science. You're right. We study lots of things here. We study things about life. We study things about chemicals. One of Tina's favorite subjects is chemicals. A lot of experience, lots. And we study about science, the world of alchemy, the world of all things natural and unnatural. And when we do that, we like to make sure we're nice and clean and tidy, and that we don't offend anyone by, say listen, you got a little cord hanging over the lens there that I could help with on the other side now. Yeah, oh, there you got it. We do the gloves, we do the magnet touch gloves. Now I got a lesson here. Go for the thumb. Oh, geez. All right. Okay. You know, I don't think I did that quite right. I don't think I did. I need help. I mean, a lot of people have told me that, but it's getting serious. It's getting serious. Jeez. Okay. Oh, and then I get kind of all twirled up. That's nice. All right. Go for the thumb first. That's what they say. I've heard that. Go for the thumb. You see now, these other fingers sneak around in there to not go there, and it's kind of sticky in there. Not kind of sticky like, you know. I think in there would be slippery would be nice. I mean, that would be a right on there like that. Okay. Ooh. Nice. So, the book we're using today, boys and girls, the experiment that we're going to do is out of Janice Van Cleve. Doesn't she sound hoity-toity? Janice Van Cleve. I see her with a martini. Not with something stuck up her veins, but with a martini. I do. That's how I see her. And help! My science project is due tomorrow. That sucks when that happens, isn't it, kids? So, what we're going to do is this experiment called in and out. In and out. In and out. And I wonder what that means. It sounds kind of dirty. It does. But it's not. It's about this. Now you're going to need an adult helper. Get an adult to help with a potato and a knife. Ha! 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 Oh, Psycho, good movie.
Here, pussy, where can you be?
Oh, that shower scene was incredible. Jeez. Okay, potato, knife. And what you're going to want to do is have an adult friend, help you cut slices. Now, as you can see here, cut slices about like that. Just about like that. That's just nice. Now, I had taken lots of liberties, but I have taken the liberty of pre-preparing them. Now, we took a half hour ago, we put these potatoes in a glass of water, just water, that's it. H2O, hydrogen, 2 parts, oxygen, 1, H2O. Got it. There you go, cheers. Oh, not vodka yet. It's not vodka yet. Okay, so what we're gonna do is take the unsoaked potato. Take it. And you're gonna bend it. Now get a close-up on that. See what happens when you bend it. How long before it snaps? Like me. How long before it snaps? That was quite a while. That was a little workout. Okay, that took some time. Now I wonder what happens to the one that was soaked in water. What is it? What's going to happen? Okay, let's go. Are you ready? Jeez. I think there. That was a little harder. I wonder if that's the way it's supposed to be. I'm not sure. Let's try the one outside of the water again. Side of the water. Okay. Let's, one more time, one more time. The second one took longer, the second one. Oh, the screen isn't turned my way, but hell's bells. Okay, are you ready? Oh, that snapped really quick. Now let's see the water one again. Water, potato. Are you ready? Are you ready? Watch. Oh, it's so flexible and snap. So what did we learn here? We learned about osmosis. Osmosis. That a lot of people think is just something that happens through your bloodstream when you drink a lot. Comes to the surface, and that's like osmosis, and you smell like a bar. But that's not what we're talking about here, is it? We're talking about osmosis is the movement of water through a type of membrane. A membrane. A thin layer of animal or plant tissue. This membrane selectively allows materials such as water to pass through. It says, welcome through, let's go, welcome through, let's go. Fun. Each cell in the potato has a semi-permeable. That means not quite permanent, semi-permeable. Talking about permeable, it's been a long time. A sec. Ooh. It's been a long day, kids. But anyway, let's get back to that semi-permeable issue. Semi-permeable membrane around it. It has a membrane around it. Mind out of the cutter. Inside each potato cell is a solution, which is a mixture of solute, the substance that is dissolved. Dissolved. The substance that is dissolved. I said that. And a solvent. So it has a solute, and a solvent. I'm looking for a solvent to solve my problem. I think that's another word for that. That's a good thing. The solvent is the thing that does the dissolving. When a solute dissolves, it's broken into small particles and mixes thoroughly with the solvent. The cell solution made of water, the solvent, with different solutes dissolved in it. Tap water is a solution with very low concentration. ADD, who knew? Tap water has ADD. Or in my world, we like to call it ODD. I got ODD, just a little odd. In this investigation, the solution outside the cell, the tap water, the said tap water, has a lower concentration of solute and a higher concentration of water than the solution inside the cell. Therefore, the tap water is a hypotonic solution. A hypotonic solution. Kids, you're going to need to know that. I can't tell you how many times in conversation that's come up. Well, that's a hypotonic solution. It happens a lot. So what happens? When a cell is placed in a hypotonic solution, water moves into the cell and decreases the pressure inside the cell. Water moves through the semi-permeable membrane to the side with a low solute solution to the side with a high solid concentration. The pressure inside a plant cell due to the presence of water is called a turgor pressure. Turgor pressure. Turgor pressure. That's important too. As the water inside the cells increases, the turgor pressure increases and the water-soaked potato slices feel firm. The potato slices feel firm. We saw that with our own eyes, didn't we, kids? We saw that with our own eyes. Yes. So, as a result, the turgor pressure of the potato slices not placed in the water may have decreased slightly due to a loss of water in the water from inside the potato cells moved out for the cells. Simple as that. What did we learn today? We learned about osmosis. Remember, that is a membrane, a semi-permeable membrane with a solution and a solvent. It's all got a, what else? Turgor pressure, hypnotic solution. It's all good stuff. It is. Kids, boys and girls, friends, family, love ya. I can't tell you how much joy it brings my heart to think that I'm teaching you stuff. So welcome once again, and thanks for visiting Test Tube Tina's. Goodbye, everyone. Take care.